Good morning, everybody. Welcome back to lecture number 15. Happy National Day, lecture 14. Today, last time, so an announcement for the homework. I will create a new homework. I will tell you directly what is the air gap cross-sectional area of A and B. Okay? Today, we have revision 8. You make sure to use the latest revision. Today, we will pretty much talk about the exact model of the transformer. So what do we remember? We remember the exact model of the transformer before. And what did I tell you? We have one ideal transformer here. We have parallel component for core losses, they are heat with RC, and magnetization losses with J times XM in parallel. Why? Because for example, if you have big transformer, would you expect big magnetization? Yes. Smaller one? Smaller. And remember, the power is proportional to V square over R, so that's why we put it in parallel. That's why we put it in parallel. And then we have two series components, RP, JXP, RS, JXS. RP and RS are primary copper losses. RS is secondary copper losses. They are in coils made of copper, and they have losses appear as also heat. We have JXP, JXS to represent the leakage. What is a leakage? Fringing, if you have an air gap. The current leak, the flux leaks between the coils. يعني في الهواء. So how many components? 1, 2, 3, 4, 5, 6 on top of the ideal transformer. Keep in mind that the relationship EP over ES equals to A, where A is NP over NS, is only applicable in the ideal side of the transformer. The ideal part. This is the ideal part. Same thing, IS prime, which we call it before IP, is 1 over AIS. IS prime over IS equals 1 over P. The terminal voltage and the terminal current, terminal يعني measured at the terminal VP does not equal to AVS, otherwise we'll be cheating. Clear? The primary current entering the terminal does not equal to the primary current leaving the terminal. It's very important. Many students get confused. They put notation IP here, which is wrong. You need to put a notation IS prime. Did you watch the YouTube videos when you were at your business trip?
Actually.
Did you fly business class?
No.
You didn't fly in business class?
Okay.
Inshallah in the future.
Sure.
Aramco, they fly in business class. Business class is better. Always. So IS prime is not IP. Why? Because we have KCL here. What is the KCL here? Really, what is the KCL here? Apply a KCL at this node.
It's IS.
No, IP equals?
IP equals IS plus IE.
Not IS, that's not IS.
IS prime.
IS prime, you have to use the right terminology, plus IE. So the primary current is the current that goes into the ideal transformer, which is the reflected current of the secondary, plus the magnetization current. Now, reflection. We need to reflect for example, there are two types of reflection. reflect the secondary components to the primary side, or reflect the primary side to the second component to the secondary side. Here, we are reflecting an XS with RS to the primary side by multiplying it by A squared. A squared, which is MP over NS. The moment I do the reflection, I can allow IS prime to move, or to go through with RS prime and XS prime. So instead of two electric circuits, I have one big electric circuit. Not only that, VS, I have here VS prime. What is the relationship between VS and VS prime?
It's good.
Reflection, A. So you need to do VS prime equals AVS, IS prime equal 1 over AIS, RS prime equal A square RS, JXS prime equal J times AXS. These are the relations. When you do reflection, you multiply by turns ratio voltage, you divide the current by turns ratio, and A squared to, this is EE to 13. Remember? EE to 13. Now, I shouldn't try it with the green because they don't appear in the camera. But what is EP? EP is the voltage that appears in the ideal transformer. If I do reflection, can I do a KVL here? Yes. And this is the KVL. Voltage rise or voltage drop? EP minus voltage drop. IS prime times RS prime plus JXS prime minus VS prime. If you do the math, you'll get this equation. This is important. Now, what if another student wants to do reflection on a secondary side? What they need to do is they need to divide by A. So VP will be VP over A. IP prime is going to be IP times A. RS prime is RP prime is RP over A squared. JXP prime is J times XP over A squared. هذه from primary to secondary, وهذه from secondary to primary. Or memorize these equations. Okay? Get it?
Yes.
Memorize it. That's the only way. If you don't want to know the equations, you have to memorize it. Okay?
Okay.
Or maybe if the problem tells you to do so, the problem will appear. So these equations are memorized, okay? Sometimes he gives you the circuit in the exam. What else we have? I am not going to do the practical considerations until I do a numerical example. Once I do a numerical example, you will understand why we do a practical consideration. So there is an example here called, before we go to example, let me remind you about some terminologies. About some terminologies. We call VS the load voltage. So it is a common practice. I told you we call it primary, secondary, left and right. Some people call it source and load. So some people with the terminology, they say VS is the load voltage, not VS prime. Is VS prime the load voltage? Do you connect the load على الموديل here? على الموديل? You connect the load هنا ولا you connect the load هنا ولا هنا? You actually connect it هنا. So we call this a load current. It's not VS prime. V's prime is the load volt. I'm sorry, not the load voltage. The load voltage reflected to primary, which is reflected to source. في بعض الكتب ما يقول لك reflected على السكندري والبرايمري، يقول لك اللود reflected على السورس. Get it؟ اللود هو secondary والسورس هو primary. Get it? So that is the purpose of the terminology slide. It's not only that. IS, is it the load current or the load current reflected?
Load current.
It's the load current. IS prime is the load current reflected. I don't like to use the word reflected. Just use reflected. It's better. Reflected has more meanings than referred. Same for an impedance. This is the impedance of the load side referred to primary resistance and reactance. X is the reactance. The bottom line from this slide is load is secondary, source is primary. So how many exact circuits we have? This is the load reflected to source, وهذه source reflected على load side. And you can see the equations written on those pictures. Okay? These are the two exact models that they use them in modeling software, Simulink, والأشياء. I'm not going to show you an approximate, I'm going to show you the VIP example. So here we have a VIP example. What does a VIP example mean? It's very important problem. How to solve this problem? First, a single phase. What is the implication of the single phase?
An AC cell.
I'm not dealing with three-phase system. If I don't deal with three-phase system, what does that mean? The power equations, they do not have threes or square root of threes.
Line to line equals the source.
There is no line to line for single phase.
Equals the source.
No, that's a wrong terminology. There is no line to line because you only have a single line. What is the other line?
The ground.
No, that's not a line.
Okay.
You have to use the right terminology, otherwise you will not get the job when you do the interview. If you show up in the interview, tell them single phase, line to line voltage. No, we don't. Thank you for your application. Please, never ever mention single phase transformer line to line quantity. لأن الفكرة من line to line إنه يقول لك phase to phase. يعني phase A to phase. Line of phase A to the line of phase B. So what is the implication? This is another implication. Thank you for bringing it, but it's useful. We're here to learn. And those who learn more, they get more jobs. They get more jobs, they have more freedom. When they get more freedom, they can put their conditions and increase their income. Simple. Now, are those numbers 25 kVA, 440 over 20, 60 Hz, are those operating values or rated values?
Rated.
Rated. What does rated mean?
Fixed.
No.
Fixed. No. Rated.
Rated, it means if we operated at these values, we are safe. Rated means it was designed for these operating conditions. At 25 kVA. Anas, this is a parent power or real power?
Period. No. Period.
25 kVA, a parent, real, reactive complex. Which one?
Reactive.
Wrong. This is a parent power. Major is coming in 1 month, approximately. So we will have many major. Thank you. We will have many major because of you. When do you want the many major? We have to have a major. Well, we have quiz. Quiz 3 is going to be the mini major. Quiz 3 is going to be the mini major.
Full lecture.
Yes, for the mini major. Mini major.
We'll
We'll talk about
the mini major or the major itself. It will include
everything from the beginning.
model 1 and 2.
Everything. Otherwise, we started to forget.
What about the major?
Majors from lecture 1. We'll talk about it, but we really need to have a mini major, at least on the magnetic circuit. Thank you for. This is apparent power. This is what? Apparent power. What is A? Mash'abi, what is A? Turns ratio. Number, give me number. What is the number A? Turns ratio. Do it. 440 divided by 220.
Yes.
2. Make things easy. So, this is A. So what is my A? I should not write in green. What is A? 2. Now, can I redraw the circuit? Why not? What is here? Vs prime. What is here? Vp. What is here? Rp, JXP, RC, JXM, RS prime, JXS prime. What is this voltage here I told you? EP. What is this current? IS prime. What is this current? IP. Anything I'm missing? No. The question is telling you transformer delivers 20 kilowatt. Is this operating value or rated value? Operating. So the transformer is connected to a 20 kilowatt at 0.8 power factor lagging. What does that mean? It means, am I connecting the load here? No. I am connecting the load عند المربع الأصفر في السلايدات هنا. So when I do calculations, I deal with VS and IS, not VS prime and IS prime. So when I connect the load, this circuit is referred. Either I refer a load على source, or I do separate calculation. I prefer to use separate calculation. So at load side, not shown above, because this is the reflected side. I have the equation, I need IS magnitude. So when I connect the load, and I know real power, I know the power factor, I know V. Can I get the current? This is module 1. Now we have to study module 1 to prepare for course 2 next week. Told you. It's not a joke. What is IS magnitude? Is P over. Do I need to divide by 3?
No.
Because single phase.
Shabib, do I need to divide by 3?
Yes. No.
Why?
Single phase.
MashaAllah. Good. Divided by V S times cosine theta. Okay, what is 20 kilo divided by 220 times 0.8? What is the answer? Calculator. Remember, this is before the reflection.
كم 230
22 114
Hmm?
113.6
113.63 amps. Now, is this magnitude? We need to find an angle. What is Theta, is it leading or lagging? What is theta? Plus or minus? Plus, lagging. Cosine inverse of 0.8, which is plus 36.86 degrees. What is theta? Is theta V minus theta I. Remember this equation?
Yes.
I'm taking Vs as a reference, so it is 0 minus theta I. What is theta I?
Minus
Minus 36. So this implies Is equals 113.63 angle minus 36.86. That is the right answer. Now, we need to move forward. We're a little bit behind. Any question about it? If it was the three-phase, then we need to have the square root of 3, line to line, ماشية. What is Is prime? 1 over AIS. Easy. Divide by 2 this phasor. 56.82 and 36.86 amps. Now, go back to the circuit. In order for me to get VP, I need IP and EP, correct? So let's get EP first. KVL, voltage rise or voltage drop?
Rise.
EP, rise, minus IS prime times RS prime plus JXS prime minus VS prime. Yes, minus equals 0. What is RS prime? It's written in the cell. A square RS, which is 4 times 0.04, which is 0.16. If you do the math, XS prime is JXS prime is J times A square XS, which is J times 0.32. You do the math. It is 4 times 0.08. What is VS prime? Mary, I asked this question before. What is VS prime?
A times VS.
Okay, what is A?
2.
What is VS? From the problem. Low voltage side with 220. Or 40 volts. So calculate with me EP. Calculate. Okay, who's not using it? Why you're not using a calculator? And then you complain, I don't know how to use, oh, I wrote this. Please, use the classroom as an opportunity for training. You miss the class, you miss the training.
أنا عندي سؤال 440 220 حق البي برايم بي اس برايم ولا بي بي وبي اس؟
No. The VS prime is 2 times 220.
لا أقصد اللي بالمسألة الحين 440 220.
هذه الريتد فاليوز حقت الترانسفورمر. بمعنى القيم هذه الترانسفورمر is rated, tested at these values. It's not real values عليه. نيم بليت يعني الحين لما اجيب لك سياره اقول لك عكي كم عزم السيارات؟ عطني عزم حصان هورس باور 200. هل انا 200 استخدمها طول الوقت؟ معناته ان في الريتد كونديشن في ال 200 حصان تعطيني هذه الاشياء، هذه القيم، هذه السرعه، هذا الشيء في ال 200. بس أنا ما اسوي العزم حقها دائما 200. سيم فور الترانسفورمر. العزم حقه كذا 25 kVA.
طب 220 اللي تحت.
At these conditions it was tested. هل تجي تحت؟ اللود صدف انه عنده هذا الفولتج.
اللي هو بي اس برايم.
هذا بي اس برايم. مو هذا الفي اس برايم، هذا الفي اس برايم. هذه تستخدمها بس تطلع الريشيو حق الترانسفورمر. الترانسفورمر جهاز باسيف element، دخل شيء يطلع شيء. Don't say this is VP, this is VS. Wrong. The only thing you get from the rated values is ايش؟
ليه؟
A. That's it. Let's do the math. Who got it?
475.277. Angle minus angle.
457, you mean?
Yeah.
That's wrong. It should be 458.27. Angle 1.137. That's okay.
دكتور الانجل حق الكاميرا هنا نيجاتيف صح؟
الانجل حق الاي اس is minus 36.86. IS prime. Just plug in numbers. Who didn't get it? YouTube. Who didn't get it? Contact me if you're not able to get it, please. We will have this in the exam. Maybe. Is it clear how we got an EP?
Yes, sir. In the equation, we should use IS prime. That's why I got it wrong.
And VS برايم also.
I already have it here.
I know. I looked at the equation.
كذا.
Okay? Everything has to be prime. Thank you. خلاص?
باقي يجي الاكس برايم بعد.
Okay? If you get stuck, you can use this equation. We already wrote it for you. This equation. Now, to get a VP, what do I need to get? To get a VP, I need an IP. I have this, I have this, I have an EP. So what is IP? Grain, what is IP? That is correct, but let's use it simple. IM plus IS prime. What is IM?
EP over
EP over C.
plus
That is correct. But I'm gonna say it's eddy plus mag current, صح؟
Sorry.
ايش هو الادي؟ EP over RC plus EP over JXSM. Get it?
Yes.
Let's do the math. I have EP, I have RC, I have EP, I have XS. Quickly, do it. Do it. If you don't have calculator, let me know. What was your question?
I didn't get it.
An IP is IM plus IS.
Yes, I am.
Prime. An IM is IM1 plus IM2. An IM1 is EP over RC اللي هو الادي current. والIM2 اللي هو EP over JXM magnetization current. Maybe a trick in the exam. Calculate the magnetization current.
Victor, what's the value of the RC?
It is written 270 ومية. Please do the VIP example at home. I want IP quickly. 4.88 at what angle?
Negative 68.
Correct. Point.
0.5.
So what is IP?
Summation.
61.03 at angle minus 39.27. Do it by calculator. YouTube, do it. I already did it.
Yeah.
I got the same.
Yeah.
Finally, I need to erase the board. We need to calculate the VP, the terminal voltage. We need to do KVL here. Let's do KVL here.
كل هذه مسألة واحدة دكتور.
Yes? Yes? What's the problem? Everybody's doing it. It's required. Told you, solution in class, should have taken photos or YouTube. It's a VIP problem. This problem, if you solve it, you can solve any other transform. Teaches you a lot. That's why I dedicated the whole lecture. And we are late still. We still need to cover an auto three-phase transformer. We still need to cover more items, so we are late. Maybe I'll ask you to attend one more lecture. Because of the holiday and because the fake quiz. What is VP? Voltage rise or voltage drop?
Rise.
Always start voltage rise. Minus IP times RP plus JXP minus EP. A smart student would change this negative to equal and would make this as a plus. So 1 minute in the test. So the smart student already had IP in his or her calculator.
Yes.
So a smart student would do what? Would do answer, which is what?
IP.
So a smart student would say answer times open brackets. Don't forget the brackets. What is RP? 0.16 plus J times 0.32. And then we'll add to it the answer in EP, which is 458. A smart student should have got this answer.
وش هي الاكس بي؟
478.4 angle 2.15 volts. XP is 0.32. So let me ask the blue 2.15 with reference to what?
الفولتج اللي كانت الاي بي.
Wrong. ده هو. Reflected ولا not reflected? Not reflected. The original 220 حقت اللود. So now every angle you have seen 1.13 minus 68 plus 2 is with respect to load voltage. You don't have to. You are asked to find the source. Are you going to put your reference in what you're asked to find for?
Okay. Yes.
The art of thinking clearly. It's an art. Please master this art. The reference here is a 220 angle 0. Now, we got a complaint that this problem is too long, and you are right. So there are approximations. There are approximations. The first approximation, they say, let's pretend that RC is much larger than RP, which is much than RC. I don't know them. But what I noticed, one good approximation is IP is small. IE is small. So, not only that, EP is 458, VP is 478, 20 volts. Can I merge them together? So this is pretend, not real. We pretend to shift this to here because EP is for 60, this is for 75, roughly. Is it a good approximation? It depends, but you can survive it. What benefit I get here? We did 2 KVL and 1 KCL. With this, you get a discount of 1 KVL. Because you end up doing EP equal VP, so that KVL is not used. You get 1 discount. If you are too lazy, many students, if they get stuck in the test and write this down, if I got stuck in the exam, I should use this circuit. This circuit would drop the magnetization core. The ADN. I'm going to pretend there is no core losses, there is no magnetization losses. It's better than getting a 0. And they use this circuit. Is it easy circuit? Yeah. VP equal IP times all the resistances minus VS equals 0, V prime. So if you use this circuit, you'll get 7 or 8 out of 10. It's better than the 0. So if you're complaining about this circuit, if you see this problem, maybe you do this circuit and get 8 out of 10, 7 out of 10.
دكتور لو سويت الشفت هذا كمان برضه تفيد الريجكت.
Students tend to do this or the exact. They don't like doing this. They don't like it. For some reason, I know. But you can do that. Or he might impose this on your exam problem. Ask you to use this approximation.
لأنه هذا أنت لو طالعت فيها حتصير عندك 3 impedance parallel خاص.
No, mean that 3 impedance parallel. For
لا
where?
السيريس هذا كلهم يصيرون.
Where is the parallel? This circuit?
لا اللي فوق. أنا عندي
هذا؟
الاثنين دول والأربعة كلهم دول السيريس.
This and this are parallel, not parallel.
all of that. صح.
This is not parallel here in the cloud.
صح.
No. That's why students don't like it.
أقدر أسوي
You still have to do KCL, EIP equal IE plus IS prime.
أقدر أسوي source transformation وأحول الفيل.
No. I don't like source transformation. I don't know how to do it. Why use source transformation?
لأنه في برا فاستغل.
No, ما في شيء اسمه استغلال. No, that's not the art of thinking clearly. Please. Do you have the camera running?
Yes.
Okay. The bottom line I want to teach you is, we will end up the lecture early today. What I want you to do is understand that we can always make approximation. Here he assumed excitation current is very small compared to primary current. What is the excitation current? اللي كان 4. What is the primary? 61. هل 4, 61 less than 2.23%? And you can move this. But this is, the way I taught you is do this example and then do the approximation, then you'll understand why we do an approximation. So the VIP example is a must. You have to do it, okay? Next lecture we will do another example that talks about voltage regulation, efficiency, and this example. And I'll talk with you a little bit about the 3-phase transformer. And then we'll end the module 2, I would say maybe by next lecture. So we are on track. Maybe I'll add an additional lecture. So what are the components of our course so far?
3-phase system.
I have introduced to you the module 1 where it talks about 3-phase system, line to line, etc. We introduced the line voltage, and then we talked about magnetic circuits. And we talked about what? Transformers. Next, once we're done with transformers, we'll start with the DC motors. Synchronous generator, induction motors. So talk about motor, generator, motor. And then move the course with power electronics, etc. I want you to study, when you study, for example, today we talked about Al-Angle. Al-Angle is chapter 1. So you really need to keep studying module 1. When we have the mini major, which is going to be quiz 3. Quiz 3 is the mini major. We will have more than one problem. Okay? So you have to study hard. Please. I know the major exam is what? October what?
22.
It's too late. So maybe we're going to target our mini major early October. So that you don't forget. Okay? Do you have any questions? You're free to go if you want. Finish 2 minutes before.